One of the items that we often talk about in systems design is the reliability of the entire system. And so in this video, I want to discuss calculating the reliability. You'll see this in supplement 4 of the Stevenson Operations Management textbook. There are a couple of concepts I want to make sure that we get through first. First of all, reliability is the probability that a system is going to be able to stay functioning. That means that if we take the reliability or the probability that it stays in system, the reliability, and add that to the probability of failure, then we should end up with 100%, correct? That means that we can rearrange this equation and say, the reliability is 1 minus the probability of failure, or that the failure is 1 minus the reliability. When we're looking at systems, oftentimes one of the things that we talk about is a system in series or is it in parallel? We'll talk about series at first. If we have one item, one component in a system, and the probability of it being able to function, the reliability, is 80%, then again, the reliability of that is just 80%. Now, what happens if I put another system with it? So I have an 80% chance that this is going to work and an 80% chance that this is going to work. Remember back from probability that if we have two events that are independent of each other, we can use the multiplication rule, which means that it's the probability of this event happening and the probability of this event happening. I'm going to click on this answer because you can see that it is the probability of number 1 happening and the probability of number 2 happening. So that drops us down to a 64% chance that this is going to remain operational. It also means that there's a 36% chance that it's going to fail. We can continue this again by adding another component, and as we would expect, that is nothing more than the probability of the first thing happening, the second thing, and then the third thing. Next, what happens whenever we add another component as a backup? We should expect, if this is the primary system and it continues to run, unless it fails and then a backup kicks in, that adding a backup would increase the probability that the system would function properly, right? So conceptually, adding a probability a backup means that we are going to increase the overall reliability. Well, in this case, we need to switch from our idea of probability of it staying functioning to whether or not it will fail, all right? If we switch to the concept now, we're looking at the probability that the primary will fail, that's 1 minus 0.8, and the probability that the backup will fail, 1 minus 0.2, because if the probability now of both of these failing at the same time, we can use the multiplication rule, right? So the probability of the system failing is 0.2 times 0.2, right? It's the primary backup failing and the backup failing. That's 0.04. That's our failure rate. We know from what we've just stated before that the reliability is 1 minus the system failure rate. So again, we had a 0.8 or 80% chance that it functions correctly on its own. Adding a backup with the same 0.8 increases our overall system reliability to 96%. Now, next part is that we will go into more complex systems. Most of the systems that we have out there are an absolute conglomeration of multiple steps, where we have one component, a second component with a backup, and then a third component. When you're calculating the reliability of each of these, you need to think about each one as a step, okay? This is a step, this is a step, and finally, this is a step. Once we look at them as steps, we can, again, calculate the probability of it staying together because we can take the probability of step 1 times step 2 times step 3. For instance, reliability of step 1 is 0.8, Similarly, reliability of step 3 is 0.8. Reliability of step 2 is 0.96, okay, because it is 1 minus the failure rate times the failure rate. And then the final system reliability is the probability of step 1 times step 2 times step 3. That gives you an idea of all of the different ways that we can look at these complex systems. So one of the things that I want you to do next is go through and look at a series of questions. I've put them out here for you to where you can go in and answer the question out here in this yellow block. Everything should make sense until you get down here to question 4. Question 4 goes into an idea of, or to a concept of, as an operations manager, you're going to need to make a decision at times on how to improve the probability or the reliability of a system. We can improve the reliability of a system either through increasing the reliability of a single component or by adding a backup. When we do that, we do add a cost. Adding cost goes into this idea of a return on investment. How much benefit for each one of the investments that we put into the system. In this one, I want you to consider 2 different options. Option 1, improve the reliability of step 3 from 0.85 to 0.95. That cost is $10. I want you to compare that to option 2. Option 2 is to add a backup to step 2. All right, so it's to add another component. The component's going to have a reliability of 0.8. All right, and it will cost $15. Here's a hint on how to do it. First of all, calculate the reliability of option 1 and the reliability of option 2, and then calculate the ROI for option 1 and then option 2. All right, good luck.